Lesson 2.1, quadratic functions, where we should learn. Analyze graphs of quadratic functions. We're going to write quadratic functions in standard form and use the results to graph a function. And we're going to find the minimum, maximum in real life applications. So a quadratic function is just a polynomial function. That's it. So you're like, what's a polynomial function? Well, it's a function in this form. So you have a number, like 3, a variable, and then a power. Right? Anytime you have a string of those, the power always has to be a positive, non-negative number. You have a polynomial function. So something like this is a polynomial function. You could just also just go like super basic. That's a polynomial function. That's also a polynomial function. Right? So all these types of things. The key thing is that this degree here has to be a positive power or 0. When we get more into it, polynomial functions are classified by degree, so by the highest power. So this is a polynomial function with the highest degree of 4. Right here we have the highest degree of 1. That's called a linear function when the highest power you see is 1. When the highest power you see is like 0, like there's no variable, it's called a constant function. And in this lesson, we're going to do when the highest power is 2. That's called a quadratic function. So you see right here. This is the standard form of a quadratic. And you see that a lot today. So the standard form of a quadratic function is ax squared plus bx plus c. Now we talked about quadratic functions before. Here's like the general library of our quadratic function, right? It looks like this, x squared. We know we can move it up, down, left, right from this. This is our parent function. The domain, the range, the y-intercept, all the useful information right there. Now if we look at basic characteristics of a quadratic function, right? So the same thing we talked about before, but now we can also move our quadratic function up and down, right? What's the intercept? When's it increasing? It's increasing. It is an even function, right? You cut in half like a book, fold in half like a book. Here's the key thing. This is when it opens up. That's when the a in front. So right, we have a basic quadratic function like this. When the leading coefficient's positive, it opens up, and we're gonna have a minimum function. Right, you can see that's the lowest point. That's a minimum. When the leading coefficient's negative, and then we have a graph that opens down, and we have a maximum function. Right, you can see that right here, right? It's opening down, we have a maximum. So that is one key thing. Like all this stuff talked about before, we want to know if the leading coefficient's a positive, it opens up, you're going to have a minimum, you have a lowest point. If the leading coefficient's negative, it's an open down, and you have a maximum point. And then it's a little more information, but same thing we talked about. Okay, let's sketch these. Now again, we should, from previous chapters, you should know how to sketch these. We can graph it. Here's the basic function, our parent function. Right, x squared. And then this first one here, all we're going to do is, let's see, inside opposite, outside follow. Inside x opposite. Outside y follow. So here I actually have two outside things. I have this, we're going to go up 1. And we have a negative x squared, so that's a flip. It's a vertical flip. Right, it's on the outside, so we're going to flip it up and down. So our graph's going to look like this. And then we're going to go up 1. Our graph will open down. Right, so all our basic graphs we should know. The next one, b, this is a. Right, we have x plus 2 squared minus 3. So I'm just going to, for our benefit, I'm just going to graph the parent function again so you can see what it looks like. I'm just doing a sketch. So that's our parent function, right? Not the right slope, but it's just a sketch. What does this thing do to it? Well, we're going to move inside opposites, we're going to move left 2. Outside follow, we're going to move down 3. So our new vertex is going to be negative 2 and negative 3. So negative 2 and negative 3. And we got a parabola. Right, so all those same rules still apply. What if I give you a parabola in standard form? Oh, okay. So this book's a little different. They're calling this standard form of a parabola. That's not generally considered standard form. So we're going to change this. This book's a little funky. Standard form of parabola is what we talked about earlier. It's when you have it like this, y equals ax squared plus bx plus c. This should be called vertex form because it gives you the vertex right away. So we call this vertex form of parabola. So that's what they should mean. They should, what happens if you have it in vertex form? So this is considered vertex form. because it makes it really easy to find the vertex. So we have our A, which is kind of like our slope, and then we have our H and K. Notice what it says right here, your vertex is HK. It's like what I did up here, right? Inside opposite, outside follow. I found my vertex. My vertex is negative 2, 3. You did the opposite of the outside, the inside, sorry. You did the opposite of the inside, and you follow the outside. So that's vertex form. So when you have it like this, it makes it really easy to graph a quadratic. The problem is, how do I get there? How do I go from standard form to vertex form? That's usually the problem here, because vertex form is easy to graph. But if I give it to you in standard form, you have to convert it to vertex form. And that's a little more work. There's generally two methods. I'll show you both methods here. The most popular method, the famous one, is complete the square. So we'll review that. And then my method is find the vertex. We're going to use the axis symmetry. So we'll find the vertex, and then we'll use that to put it in vertex form. So that's actually my preferred method most of the time, but we'll show you both ways. So method 1, we're going to identify the vertex with this, right? So I'm going to complete the square. So if we remember how to complete the square, we'll say y equals 2x squared plus 8x plus 7. So this is going to be complete the square method, which is like the more correct, this more mathematical method. There's many times in higher math that you have to complete the square, so you should get used to it. Now, it's not my best way, it's not my favorite way to do this, but it is the more proper math way of doing it. So to complete the square, I like to get the x's by themselves, or move over that. So we're gonna move over that 7. So I'll go minus 7, and I get y minus 7 equals 2x squared plus 8x. So I'm gonna say iso the x's. Now here is the more fancy complete the square. When you complete the square, you cannot have a number of the x squared. There shouldn't be a leading coefficient higher than 1. So what we're going to do here is we're going to factor out a from ax squared. So I'm going to factor the 2 out from here. So pull out the 2. There's an x squared. 8 divided by 2, right? When you factor out, you divide. 8 divided by 2 is 4. I'm going to leave a little space, you'll see why. And then we have this. So we factor out the A, we have this. And now we complete the square. That's my next step. We're going to complete the square. Complete square. Now if you forgot how to complete the square, it's where you get the middle term, the B. You divide it by 2 and you square it. You're going to add that to both sides. Add this to both sides. That is completing the square. That makes it a perfect square. So we're going to get the middle term, our B term, in this case 8, or in this case 4. We'll do it in a second. And then you can divide it by 2, and then add it to both sides. So here, I'm going to get my 4. I'm going to divide it by 2. We're going to square it. So I'm going to get 2 squared, which is 4. So I'm going to have to add it here. And I'm going to add it also over here. Now, with one caveat. Oops. 4. Caveat being, if you add 4 here, again, this is a more fancy complete square. If you add 4 here, it's getting multiplied by the 2. So on this side, you're actually going to add plus 8. Right? I went plus 4, but it's getting multiplied by 2, so this has a total value of 8. So we're going to add a total value of 8 on this side. So that's the way it works. But again, this is a little more fancy because there's a number outside. But whatever we added this side, we got to add this side. In this case, we're adding 4, but it's getting multiplied by the 2 out here. So we're going to go 4 times 2 at this side. So that's where the 8 came from. Okay, so I'm going to simplify this a little bit. Negative 7 plus 8 is positive 1. This side, now when you complete the square, this should be able to factor it. And the trick is, it's always a thing before you square it, every single time. So we're going to factor this guy. And it's always the number before you square it. And you can just factor it, it's going to be 2, but it's always, always, always the number before you square it. So you get 2x plus 2 squared. And then finally, I'm gonna isolate the y. So I'm gonna subtract 1 from both sides, and we get this. And then with my vertex, that was the question. Your vertex is gonna be inside opposite, so negative 2. outside follow -1. So there you go. So that's doing it by complete the square. So that's how you find the vertex with this by complete the square. So complete the square on both sides. That's way 1. If you're good with that, you're great. Way 2 is kind of my favorite way of doing it. And way 2, all we gotta do is find the vertex. And there's a way to do that. So let's recap, right? We start off with this. Y equals 2x squared plus 8x plus 7. So the way you find the vertex is you use the axis of symmetry formula, which is this. X equals negative b over 2a. That gets you the axis of symmetry. The axis of symmetry is also the x and the vertex. So basically we're just going to find the x and the vertex using this axis of symmetry formula. So what's a, b, and c? Well, a is the number from the x squared, b is the number from the x, and c is a constant. Just like in our standard form, right? A, b, c, right? The actual standard form. So if I substitute in, I'm going to get -8 over 2 times 2. So -8 over 4, which gets me -2. Look familiar? Okay, so we have the x in our vertex, right? In our vertex, I have the x, -2. How do I find the y? Well, anytime you have an x in any type of equation, you just substitute it in, plug it in. So to find the y, we're just going to sub into the equation. To find y. So y is just going to be 2 times -2 squared plus 8 times -2 plus 7. Remember to do this part first. So that'll be 4. 4 times 2 is 8. 8 times -2 is -16 plus 7. 8 and 7 is 15. Minus 16 is -1, just like I got over there. So there's my vertex, -2 and -1. Right, so 2 ways to do it. You can either do complete the square and get the vertex, which is the more proper mathematical way. I always just found the x in the vertex and then substituted in to find the y. And then now if I wanted to put it in vertex form, right, which isn't the question, the question is that vertex. You could, because vertex form is just this. And you have everything you need, right? You have h and k as the vertex. You have -2 and -1. How about the a right here? That's the easiest part. It's the same a from up here. Boom. So if you want to put in vertex form, which again, that wasn't the question, but it's so easy. Once you have the vertex, you just plug it in. So we get the exact same answer either way. So you can either find the vertex using axis of symmetry, or you complete the square. Either way gets you the vertex. Okay. How about how much you find the x-intercept of a quadratic function? Well, hopefully that's review, right? Find x-intercept, it never changes, no matter which math level you're in. If you want to find the x-intercepts, you set y equal to 0 and solve. Just like if you want to find the y-intercept, you set x equals 0. So this is never going to change, no matter what math class you're in. So all I'm going to do here, f of x is my y. So 0 equals -x squared plus 6x minus 8. I personally don't like having a -x squared, so I'm going to move everything. Let's divide everything by -1. Or move everything over. Same idea. So I'm going to get x squared minus 6x plus 8. And then I'm just going to factor. So I'm, right, big O x, here's 8, here's -6. Two things I multiply to get 8, but add to get -6 would be -2 and -4. So x minus 2, x minus 4 equals 0. Split it. X minus 2 equals 0. X minus 4 equals 0. Add 2 to both sides. X equals 2. And we do the same thing here. And x equals 4. So that's how you find your x-intercepts. Set y equals 0 and then factor if you can. If you can't factor, quadratic formula is always an option. Okay, write an equation of a parabola in standard form. They mean vertex form. So, write in vertex form. So they want us to write in this form. So we have good news. We have the vertex. That's our h and k. So that's our 1 and that's our 2 right there. So right now our equation looks like this. So all I have to do is find out a. because that's all we have to substitute in. And define a, h, and k. Anytime I put in a vertex form, define a, h, and k. So how do I find this? Well, they gave us another point. So we're just going to substitute this in to find a. I should say sub into x and y. Let's go back. So let's substitute into x and y to find a. So that's how we're going to do it. Step 1, sub in vertex. Step 2, sub in point, given point, to xy to find a. And then finally we're going to rewrite it all. Rewrite, I know I spelled rewrite. Rewrite with a, h, and k. So once we get our answer, we're going to rewrite with a, h, and k. So that's all we have to fill in, a, h, k. Right? So I already figured out h and k, vertex. Now we're going to plug in our point to find our a. So it works like this. Right? This is my x, this is my y. So that's going to go here, that's going to go there. So -6 equals a. 3 minus 1 is 2. Squared plus 2. So -6 equals, that's going to be 4. I'm going to rewrite this. I'm going to make it 4a. So 4a plus 2. Because the common mistake is people write it like this, which is fine, but then they just like, for some reason, add those two together, which you can't do. This is the same thing as this. You cannot add those two, right? One's an a, one's not an a. Then we're here to solve. -2 from both sides. -8 equals 4a. Divided by 4. A equals -2. And then again, final step is rewrite it all, right? We started with this. And then we're going to substitute in our value. So a is here, and then h and k are right there. So 1, 2, and -2. And there we go. That's it in vertex form. Okay, so how do we find the maximum values? So like we talked about earlier, when you have a positive a, right, leading coefficient, your graph should look like this, and you have a min. When you have a negative a, your graph is upside down, and you have a max. Now, where's that min and max at? That's at the vertex. So if you want to find the min and max values, to find min and max, is you just find the vertex. And then you want the y value, technically. How do you find the vertex? Well, we did it once already. Right? That's the way, that was my preferred way to find the vertex. We're going to do the exact same thing, because that's the easiest one to find the vertex. We're going to use the axis symmetry to find the x. Once you have the x, plug it in to find the y. So that's how we're going to find our vertex. So you want to find the vertex, is right? Use x equals -b over 2a to find x. This is fine. And then sub in into original equation to find y. Now a lot of times you'll see this as written down, and I'll explain this real quick. This is just this in math talk, right? So -b over 2a is a vertex, and notice how it's on the x value. What's f of -b over 2a? That's what this says, f of -b over 2a. That just means plug it in. Plug in your x value into the equation. That's what f of -b over 2a is. So you see it right here. Right? You'll see it like this. Right? That's all that means. Is this, oh, that's how you find that axis symmetry, and then all that means is plug it in. So if you ever see that, if I give that to you, that's what that means. So if we're going to do, let's do a real life problem. This will be our last thing. A baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second at an angle of 45 degrees with respect to the ground. The path of the baseball is given by the function f of x equals all this, where f of x is the height of the baseball in feet and x is in horizontal distance from the plate. What is the maximum height reached by the ball? So all they're saying is that you have a person here hitting a baseball, and then it goes up like this, then hits the ground. And that equation there is this guy. They want to figure out what the max height of the ball is. Well, if you look at that, that's just the vertex, right? So we just got to find the vertex, right? So find vertex, and we know how to do that. We're going to use the formula. Whoops, sorry. Negative b over 2a, f of negative b over 2a, right? Which just means, right, use that to find the x and vertex. That's the symmetry. What's my a, b, and c? Right, well, we have the equation. A is here, b is 1 because you don't see a number in front, and then c is 3. So negative b, negative 1 over 2 times negative 0.0032. I'm going to need a calculator, and that's going to get me 156.25. So that's my x on the vertex. And now we just got to plug it in and find the y, which is the max height. So we're just going to sub that in. Sub in's more correct mathematical term for it. So we're going to get negative 0.0032, 156.25 squared plus 156.25 plus 3. So that all into my calculator to get 81.125. So that's my max height. Max height reached by the ball by baseball is 81.125 feet. And that's the answer, and that's the lesson.